Okay. All right, so we're going to move on to chapter 8. And let's see here. I definitely need to turn on a light. All right, so we're going to start talking about sequences. Let me turn on a light really quick. All right, so now this can be well, like many topics here in college algebra, some people are going to like this and some people are going to hate it. But the idea here is, maybe I'll write it this way, a sub n is, so this is a formula. So I've got 2n minus 1. Okay. So the idea here is, in fact, I'm going to ask you guys a simple question. What does a sub 1 equal? Okay. And in this case, all I do is I stick a 1 in where the n is, so that's going to be 2 times 1 minus 1, which, so 2 times 1 is 2, minus 1 is 1. Okay, so a sub 1 equals 1. A sub 2 is going to equal 2 times 2 minus 1, so 2 times 2 is 4, minus 1 is 3. A sub 3 equals 2 times 3 minus 1, which equals 2 times 3 is 6, minus 1 is 5. So a sub 4 equals 2 times 4 minus 1. 8 minus 1 is 7. So you could probably, without even doing any work, guess what a sub 5 is. Landon, I'll pick on you. Can you tell me without even doing the math? 1, 3, 5, 7.
9.
9, yep, okay. But just to prove it, 2 times 5 minus 1 does indeed equal 9. So 10 minus 1 is 9, okay? So this formula here, this is one way to get a list of all the odd numbers, okay? And you could even, if with this formula, I could find out a sub 57, which is 2 times 57 minus 1. 2 times 57 is 114, minus 1 is 113. Okay? Does that make sense? All right, so let's continue to do some more sequences. This time, I did the easy one, but you guys can do them. They won't be that hard. So let's say if I had a different function, c sub n equals, and then the formula is basically n squared minus 1. Natalie, can you help me figure out c sub 1?
Would that be 0?
So you're going too fast for us slow people. Let's plug it in first.
Okay. So it'd be 1 squared minus 1.
And that is indeed 0, as you said. Okay, let's do c sub 2. And of course, I can't make subscripts on here. How about Elisa? Can you tell me what c sub 2 is?
So
it's Alyssa.
Yeah, fuck it. It would be 2 squared minus 1, and that equals 3.
So 4 minus 1 is 3. Okay. I'm doing this from memory. I can't remember who else is here. Danae, can you do C3? C sub 3.
So 3 squared is 9, minus 1 is 8.
Okay. Oops. Is 8. Okay, C sub 4. Logan, must be your turn. Are you here? Oh. Joshua Hogan, that's what I was thinking. Oh no, Logan's here. I thought you were working. Good to see you here, Logan.
Thanks. C sub 4 is, so 4 squared is 16 minus 1 is 15.
15. Okay. And C sub 5 equals, we'll pick on Joshua.
Yes, it's 24.
5 squared minus 1, which is 24. Okay. You guys liking these so far?
Yeah.
Yeah.
All right. How about if I did some sequence I sub n equals n divided by n plus 1. So that's a divide. Okay. So let's find I1. I1 would equal, Camila.
It would be 1 divided by 1 plus 1, so it would be 1/2.
Equals 1/2. I forgot about that. 1/2. Okay. I sub 2 equals, whose turn is it now? It's Derek's turn. Derek Christensen. Is there other Derek here? We've only got one Derek today. Good, I'm glad we've got a few more people here. I sub 2, Derek, is?
So it would be 2 over 2 plus 1, which would be 2 over 3.
Okay.
So 2/3.
2/3. Oh, I forgot about that. Sorry.
Or February 3rd, however you want to.
Yeah. All right. I sub 3. Seems like you guys are catching on to this pretty good. I sub 3. Whose turn is it now? Caleb, it must be your turn.
It's going to be 3 over 3 plus 1 is 3/4.
Okay. All right. I think you guys are catching on. We'll do one more that's a little bit tricky. How about this one? This one is we're going to call R sub n equals -1 to the nth power divided by 2 to the nth. Okay. Underline that so it looks like a fraction. Let's find R sub 1. Okay. So it must be Breezy's turn.
Okay, so it'll be -1 raised to the first power over 2 raised to the first power. So -1/2.
So that's -1/2. Okay, maybe I should do it that way. I'll leave it as a fraction. -1/2. 1/2, I say. Oh, it's negative though. Okay, R sub 2. Let's pick on Fidencio. It must be your turn.
All right. So it will be -1 raised to the power of 2 over 2 to the 2. Yeah.
Okay.
And that's equals 1/4.
1/4. Okay. R sub 3. Let's pick on Caitlin. It's your turn.
Okay, so it would be -1 raised to the 3rd and 2 raised to the 3rd. So it'd be -1/8.
Okay. -1/8. Okay. We'll do one more. R sub 4 And we're going to pick on Max.
So it'd be -1 to the 4th power over 2 to the 4th power.
Okay. So -1 to the 4th power, is that positive or negative?
That is positive.
Okay.
Positive.
And 2 times 2 is 4. And 4 times 4 is?
8. I mean 16.
16. So this is 1/16. Okay. Now, so just so you know, you can see here we go negative, positive, negative, positive. And so one way, if you have a sequence here, the easiest way to do that is to do -1 to the nth, or n+1 as the case may be, if you want to go positive, negative, positive, negative. So that can be a useful thing as well. Okay. All right. So okay, I'm going to open up a new page, I think, here. Let's say that I have a sequence. Can you guys figure out what the formula is? Okay, so my pattern is I've got 1/2, 2/3, 5/6, 7/8, and then it goes on forever. Can you guys figure out what the sequence would be? A sub n equals. Except for no, I did it wrong. Let's try this again. It's not 2/3, it's 3/4. 3/4, 5/6, 7/8. Okay? Maybe, here I'm going to copy this back to our previous page, and we'll make this a little bit bigger so you can see. Because there's probably something very helpful on this page that may help you, especially with the numerator. And I'm just going to throw that out for anybody.
Is the numerator going to be 2n minus 1?
That's right, 2n minus 1, okay? So we're going to use this nice formula here for the odd numbers, because we've got so in the numerator, 1, 3, 5, 7. So how would you figure out even numbers on the bottom, 2, 4, 6, 8?
Would it be 2 times n?
Perfect. 2 times n, so there you are. That is your sequence, okay? All right, now what if I did another sequence that was -2, 4, -8, 16, -32, and then it goes on forever. Can you guys figure out that formula? We'll call this B sub n.
Will not be 2n multiplied by -1 to the power of n.
Okay, so yes, very well done on that. So if we want the alternating signs, so I'm going to copy that down to here, -1 to the nth power. We'll check it out and make sure that works properly. So -1 to the nth, and then what else did you say, Sam?
2n.
2 to the n or 2n?
Yeah, not 2n.
2n? Okay, so let's make sure that works. Okay, so b sub 1, we can check our answer. So that's going to be -1 to the first power times 2 times 1. Okay, so -1 to the first power, that's negative. 2 times 1 is 2. So far, so good. So the first, except it's -2. Okay, b sub 2, let's check our answer again. This is going to be -1 to the second power, and then we're going to have 2 times 2, which is going to be +4. So far so good. B sub 3 equals -1 to the third power, and then we're going to get 2 times 3, which is 6. It is negative, but 6 is not 8. So it worked good for the first two, but not for the third one. Does that make
So
sense?
it's going to be 2 to the n power.
Yeah, 2 to the n. Let's try that. So if I put that in there, so this is now 2 to the first, which is still -2, so that works. 2 to the second power is still 4, so that works. 2 to the third power is now -8. That works. And we can check it again. B4 equals -1 to the fourth power and 2 to the fourth power, which is 16, and that works out +16. See? All right, so you guys are well done. Okay. Now let's talk. Maybe I'll leave this. I'll get rid of that one. So these are sequences. And then I'm going to create a new tab here, and we're going to call this recursion. Okay, and so the idea behind recursion, maybe I'll erase this. The idea behind recursion is that every number in the sequence ends on the previous number. Okay, so that's what recursion or recursive sequence. Let me put this in here, recursive sequence. Okay, all right, so now with a recursive sequence, I always have to define a sub 1. So a sub 1, let's say that equals 1, and then a sub n equals 3 times, this is really where I need some subscripts. Okay, it's 3 times a, and then pretend this is a subscript n minus 1. And then plus 2. Okay. So with a recursive sequence, I'm going to have to give you the first number always, and then I'll have to give you what the formula is. Okay. So as I do this, so a sub 1 is going to equal 1 because I gave that to you. A sub 2 is going to equal, in this case, 3 times a sub n minus 1, which is a sub 1. So 3 times your previous number, which in this case is 1, plus 2. And so that equals 5. Oh, that was funny that it was smart and did that. I don't want it to do that, though. I want to leave the formula there. Okay? So that's going to be 5. Okay? So now, if we do a sub 3, a sub 3 is going to be 3 times a sub 2, and since 2 is 5, a sub 2 is 5, then I'm going to add 2. So 3 times 5 is 15, plus 2 is 17. I'm going to move this over. Okay. So a sub 4 in this case is going to equal 3 times a sub 3. A sub 3 is 17. And then we're going to add 2. Okay. 3 times 17 is 51, plus 2 is 53. Okay. A sub 4 is going to equal a sub 5, excuse me. A sub 5 equals 3 times whatever the previous number was, which in this case is 53, plus 2. 3 times 53, 3 times 5. So that's 159 plus 2 is 161. Okay? Does that make sense?
Will there ever be a time where they jump to from a sub 5 equals 3 times a sub 2, like instead of jumping previous to jumping a little farther previous?
Oh, wow, you must be thinking ahead. So we have a very famous sequence called the Fibonacci sequence. Okay? Now, I know this is getting to be an old movie, but who's watched the Da Vinci Code? Just state your name if you've watched it. None of you have watched the Da Vinci Code?
I feel like I have, but that might have been National Treasure. It's been a while.
So it's got Tom Hanks in it. He plays a professor, Robert Langdon, who's this really smart guy all into symbology. And it was a really good book. And featured in the book is the Fibonacci sequence. So the Fibonacci sequence is f sub n. It's a very famous sequence in math. F sub n equals f, and then pretend this is a subscript n minus 1 plus f sub n minus 2. Okay? So in this case, because it represents the last 2 in here, f1, so f1 by definition is 1, and f2 by definition is also 1. Okay? So the idea here is, if I give you the first one, f sub 3 equals, and I'm going to write it this way, f sub 2 plus f sub 1. Okay? So f sub 2 is 1 plus, so in this case, it's going to be 1 plus 1, which equals 2. I'm going to move these over to this column here. Okay? So this is a very famous sequence. So S sub 4 is going to equal basically f sub 3 plus f sub 2. Okay? Well, f sub 3 is 2, f sub 2 is 1, and so that equals 3. F sub 5 equals the previous one, which is f sub 4 plus f sub 3. Okay? S sub 4 is 3 plus f sub 3 is 2. In this case, it's going to be 5. So it starts out 1, 1, 2, 3, 5. And then f sub 6 equals f sub 5 plus f sub 4. F sub 5 is 5. F sub 4 is 3. So 5 plus 3 is 8. And we'll do one more. F sub 7 equals f sub 6 plus f sub 5. F sub 6 is 8 plus 5, which equals 13. So this is definitely, without question, the most famous recursive sequence in all of the sequences. Now, this sequence, believe it or not, is actually found in nature. It's found in the conch shell. Let me see if I can pull up. There's a very famous building in Independence, Missouri. The Community of Christ Temple. If any of you have ever seen it, here we go. We have a picture here. Let's go to the images. Maybe that'll be better. But this building here, okay, it's supposed to represent a conch shell, and this steeple on it is based on the Fibonacci sequence. 1, 1, 2, 3, 5, 8, etc., etc. And so I wonder if you can see inside, because it's really cool on the inside of this temple. We can kind of see here, but they don't look all the way up through. But this is the inside of the temple. Don't they have another one where you can look up? Oh, this is a nice aerial view of it there. It's a very cool building. Oh, here we go. This is it. This is looking up inside the steeple. And so you can kind of see the conch shell thing. So it's a very, very cool building. If you ever get out to Independence, it's pretty cool. So yeah, so this is based on the Fibonacci sequence, conch shell. And there you can kind of see the conch shell is surprisingly shaped like a Fibonacci sequence. So that's kind of one of your famous recursive sequences. Let's see here. Okay, so let's move on. Hopefully that makes sense. Oh, I probably should have you guys do another one, but we will, on your homework, you'll have some sequences. So I just wish I could make subscripts a lot easier. It would make it easier to follow a little bit. But okay, so let's talk a little bit about partial sums. Okay. So a lot of times when we talk about partial sums, we'll use the letter S for sum. Okay. So let's say that I had a sequence which was 1/2 plus 1/4 plus 1/8 plus etc. Goes on forever. Okay. And if I said I want you to find the first 4 partial sums. Okay. So S sub 1 would be just the sum of the first term, which is just 1/2. Oh, I hate that. 1/2. Okay. So S sub 2 would be the sum of the first 2 terms, which would be 1/2 plus 1/4. Okay. And in that case, so 1/2 plus 1/4 would be 3/4. Okay. S sub 3 would be the sum of the first 3 terms, so that would be 1/2 plus 1/4 plus 1/6. Okay. Now that's going to be, we've probably got to turn everything into 12. Okay, so that would be 6/12 plus 3/12 plus 2/12. So 6 plus, I can't do that in my head. 6 plus 3 plus 2, all divided by 12, which would be, if I move these over, 6 and 3 is 9 and 2 is 11/12. So that's 11/12. Okay. S sub 4 would be 1/2 plus 1/4 plus 1/6 plus 1/8. And you can get the idea. I won't do that one. Okay, does that make sense when we're talking about partial sums? Okay. Now, let's do okay, this is where I am going to have to start turning Greek on you. Okay, I will show you this. This Greek there's a thing right here. That's the Greek letter sigma. It looks like a weird looking E, kind of. It's actually the Greek letter S. It's called sigma. I cannot make that sign. But here, this is where I'm going to pull in my, we'll open up a new page here. So the Greek letter sigma, okay? Now, a lot of times we will put some sort of an index, such as k equals 1, 2, and then we can put any number we want here for n, okay? In this case, so for example, we could do this, the sum of k equals 1 to 5 of some sequence. Say the sequence is called a sub n. So this would equal, in this case, I'm going to have to make this big, okay? A sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5, okay? And so this is what we would call summation notation. So let's do an example here where I have k equals 1 to 5 of some sequence k squared. So can you list out the first 5 terms? Who haven't I picked on today? Natalie, I think it's your turn. Can you list out the first 5 terms of the sequence k squared?
So would it be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared?
Okay, and you could put that in your calculator and figure it out. That would be, in this case, 55. 5 squared is 25, plus 16 is 41, plus 9 is 50, plus 4 is 54, plus 1 is 55. Okay? All right, well done. What if I said I want you to find the sum from j equals 3 to 5 of the sequence 1 over j? Can you do that? List out the first 5. Nathan.
It's j, 1 divided by j.
It's 1 over j.
1 over j.
And j starts at 3 instead of 1.
Okay, so I'm confused. So is that also j equals 3, or is that a
Yeah,
b?
that's supposed to be a j equals 3,
okay.
sorry.
Okay. So it's gonna be 1 divided by 3 5 times, if I understand that.
Nope. So 1/3 is correct though.
Yeah.
And now we're going to increase j by 1. So the next number after 3 is
I'm not sure how much we're increasing by. Is it just by 3? So we're just doing 1.
No, we're just increasing by 1. What's the number after 3?
4.
4. So this will be 1/4.
Okay.
Plus, what's the number after 4?
1/5.
1/5. Does that make sense?
Yeah. So because there's a 5 above that e symbol.
Yeah, we're just going from 3 to 5.
Oh.
So 1/3 plus 1/4 plus 1/5.
Okay. Perfect.
Does that make sense?
Yeah, that makes sense. Thanks.
Okay.
So the number on top of the E or the S is the number that we're getting to, not necessarily the number of times we're doing it.
Yeah, this is the number we're stopping at. This is the number we're starting at. Yeah. Okay.
All right.
All right. So now, the last thing that I want to do, I think, is talk about, this is where I've got 3 rules for you. I'm going to open up a new page. And in this case, I'm going to say, okay, so these are 3 rules, okay? If I do some sum of k equals 1 to n, whatever we get to, and then if I have some sequence a sub k plus another sequence b sub k, that equals the sum of a sub k from k equals 1 to n plus the sum of b sub k. Okay, now that can be very handy. So this is basically rule number 1. Rule number 2 says that if I have the sum from k equals 1 to n of a sub k minus b sub k, okay, so we're subtracting instead of adding this time, you can do the sum from k equals 1 to n of a sub k minus the sum of b sub k, okay, equals 1 to n, okay? So essentially, you can kind of think of that as the distributive property. You can distribute your summation sign. Rule number 3 is that if I have some sum from k equals 1 to n, now c is going to represent some constant like 3 or 4 or something like that. C times some sequence a sub k, you can actually pull that c out and it'll be c times the sum of k equals 1 to n of a sub k. Now, I really would like to do, so these rules are going to be very useful. I'm going to try to pick a homework problem. Well, they don't really give us any good things here. Okay, let me do, this is going to be problem number 56. Okay, so do you guys have all that down, all that information down? You probably want to write those down. Because I want to do problem 56 and show you why this is useful. Hopefully that's a yes. Okay. Now, let's say that I wanted to find the sum from k equals 1 to 100 of the sequence 3k plus 4. Okay. Now, I could list out all 100 things and add them up, but that would take me a very, very long time. Why are we teaching you this if we don't give you any problems to do? And I know we're out of time. Tell you what, I know we're out of time. I'm going to save this for... Did I even give you any good problems on here? You know what? I think I've taught you everything I need to know except for they introduced these properties of sums, and then I didn't give you any problems with them. Tell you what, I'm going to save this for tomorrow because I don't want to rush through this. And it looks like I didn't actually give you any good problems to use this with, but I will do that tomorrow, and I'm going to give you probably 6 more problems to do. Well, maybe 4. We'll see. Except for those, I use a graphing calculator. That's why I didn't sign them. Okay. Let me just say this. Those 3 properties I gave to you, keep those in your back pocket. We'll probably use those tomorrow when we cover 8.2. So your quiz today, quiz due tomorrow and homework due tomorrow is on 8.1. I really don't think I gave you any good problems to deal with these properties, which is too bad because that's going to be very useful. So I'll also tell you a story about a 3rd grader tomorrow. So I'll let you guys go. Quiz and homework is 8.1 due tomorrow. So we'll see y'all tomorrow. Any last questions you guys have?
Nope.
Okay. Thanks. We'll see y'all later then.
Thank you.
Thank you.
Thank you.
Yeah.
Hard.
Don't get corona.